Section 1.5 here, we're looking at graphs of functions as mathematical models and graphs telling stories. I guess that is actually the most important part of the section is that title right there. We're looking for our objectives here to describe in words what a graph tells you about a given situation. Then we're also going to do the reverse, sketch a graph that best describes the situation described in words. So those two relate closely to each other, forward and backward, the descriptions. And then we're going to talk about increasing, decreasing, and constant again as parts of the graph. And we're going to identify minimum and maximum points as a graph. Somehow that last objective happens first. Cool. And the increasing, decreasing, this is more of a reminder of what we said in the last section. This graph right here increases, it's going up left to right. This graph right here decreases, it's falling from left to right. And this graph right here is constant. It's staying the same value, the same output value as the input values change. All right, so if a graph increases and then decreases, it's going to have a maximum point. The y value of this coordinate is called the local maximum. It's called a local maximum because it could turn around and go higher on later. So if you had a graph that did something like this, for example, this would have two maximums. Maximums are just hilltops. It doesn't matter where they happen to be. If they're the ultimate top, functions can have more than one. So I just wanted to say this one has two maximums because the graph changed from increasing to decreasing there. If the graph changes from decreasing to increasing, that's going to cause a minimum or some local minima. And again, over here, this graph has two turning points where it has minima. Some graphs will just have one of each. The silly one I drew over on the side has two of each. So in this picture, again, this graph is changing from increasing to decreasing. So you can see it's a picture of a maximum point. And this graph here is changing from decreasing to increasing. So it's a picture of a minimum point. All right, so objectives 3 and 4 are taken care of. Now we'll go into the describe what's happening in words here. Okay, so this is a situation about a parking lot, or walking from a parking lot, not about a parking lot, but it's about walking from a parking lot to the library. So this is my distance from my car. This is the time in minutes. So what I can see happening here is that I'm walking away from my car at a steady point, and then the distance away from my car stops getting larger. So for this entire place, it's constant. If the distance is constant, it means I'm not moving. So I'm rummaging around in my bag, I'm standing still, and then the distance between me and my car decreases, and it decreases pretty rapidly. So I walk back to my car pretty quickly, a lot quicker than I was walking away. I might have been strolling away from my car, like whatever, but then I stop and I hurry back to my car. Then the distance between me and my car stays the same. It's also 0. So I'm at my car for a little bit of time. And then I leave my car and I head all the way to the library. But if you look at this segment here compared to this segment here, it's steeper. So that means I head to my library, but more quickly than when I first left, because maybe I'm late. So that's a lot of information that I can tell from this little story right here. So on the next page, we're going to get a chance to write some of that up in the descriptions. So as a matter of fact, I believe they write it up for our situation here, and then we'll write the story for the next situation. So looking at what's happening, the first increasing line segment indicates that you're moving away from your car. The first horizontal segment means that we're standing still. Then the decreasing line segment means that you are going back to the car. So the distance from the car is decreasing. Then when we get there, when we reach the horizontal axis, we're back at the car. Then we're horizontal, so we're staying at our car. And the final increasing segment is steeper, and so we're moving away from the car faster than we were in the first segment. All those things that we had mentioned when we saw the picture. So let's see what kind of story we can tell from the next picture here. Okay, so in this one, a person's core body temperature in relation to the time of day. So their temperature is 98 point something. Since 98.6 is about normal, I mean, this is probably not quite point 0.6 since 97, 98, 99 would be up here. It's not halfway, but maybe this person's got a normal body temperature of about 98.2 or something. Um, Again, the 0.6 is just on average for the human population, not for any specific individual. So the body temperature is about 98.2, and then it drops. It goes down to 97, maybe even down to 96. And let's see. So this is midnight. So that's 1, 2, 3, 4, 5, 6, 7. That would be about 7. So between midnight and 7, their body temperature drops. And then it increases pretty rapidly. And then it kind of flatlines and levels out at about that normal body temperature. So what I think happens here in this situation is our person was asleep. And while they were asleep, their body temperature dropped. And when they woke up about 7 a.m., their body temperature increased back to normal. So our independent variable is the time, and our dependent variable is the temperature. And we'll give our interpretation of this situation. Okay, so the person's body temperature was normal at, we can round it if we want, at approximately 98.4 degrees at midnight. But dropped during the night while they slept. Right, I'm going to color code my picture. The part that I've written about so far was about this part of it. Okay. So the next piece that we'll write about is about this next portion here. And we'll say that the person woke up about 7 a.m. Hopefully I counted that right. They woke up about 7 a.m. Then their body temperature increased until it returned to normal and then remained at that level. The body temperature increased until it was normal and remained normal throughout the rest of the day. This question makes me curious about what really does happen when we sleep. Does our body temperature really decrease? I don't know. So this picture indicates that it happened for this person. Okay, so let's look at the next picture and say what we can learn about this situation. So in the next picture, performance of a simple task in relation to the anxiety levels. We have our anxiety level across the independent axis, and we have our performance across the dependent axis. So we have our anxiety level as independent, and we have our performance. So I can notice that when I have low anxiety, I have low performance. When my anxiety level reaches a mid-level anxiety, I have high performance. But when my anxiety level gets too high, my performance also gets low. So with a low anxiety, performance is low. So that's this point right here, right? And then I'm also going to indicate that as my anxiety increases to mid-level, my performance also increases. So mid is just somewhere in here. It's like the middle, right? Increases to mid-level, performance also increases. Okay, so if you have a deadline coming up and you're starting that mid-level anxiety, your performance increases. But when your anxiety gets too high, it can negatively affect your performance. So the second half of this curve, we'll talk about how when anxiety gets too high, from mid to high, performance decreases. All right. So a couple more situations to look at here. The next one is on net profit for a particular business in relation to time given quarterly. So our independent is time, and our dependent is that net profit. Independent, dependent. So interpretation. Okay. So I'm going to say it out loud first because I might be able to say more out loud than I can capture in writing. So I notice that I've got some increasing profits right here in the first quarter. So first quarter, second quarter, third quarter, fourth quarter. All right. So increasing profits in the first quarter. Now I'm still increasing in the second quarter, but not quite as fast. So I increase at a slower rate in the second quarter. Then when the third quarter starts, we lose, and we lose everything up to where we were at the end of the first quarter. So we're back to where we were at the end of the first quarter. Then the fourth quarter takes a dramatic decrease all the way through half the first quarter of the next year. So we're not ending on that fourth quarter. We can decrease past the beginning of the new year into the first quarter of the next year. Then something in the economy changes, we start turning around, and we start making some gains in profit, some pretty good gains in profit. Gains in profit slow down and continue to slow down, but they increase throughout the remainder of the year. I can also note that while I do not end up as high as I was in mid 2010, I do end up higher than 2010 started. So we've made continual gains at a slower rate. That's a lot about the picture. I'm going to try to capture some of those details when I write this down. So interpretation. So we'll say profit increases during the first two quarters, quarter one to quarter two of 2010, but at a slower rate. At a slower rate in quarter two. Then in profit in quarter three, all of quarter two's gains are lost. In quarter four and quarter one of 2011, the company takes a huge loss. Company suffers a large loss. Quarters 2 through 4 show increases, but at a slower rate each quarter. By the end of 2011, we are making about the same as we were at the end of quarter 1 of 2010. Okay, so by the end of 2011, profits equal those of 2010's quarter 1. About the same. It looks like if I estimate, that's about the same all the way out there. Okay, so there's a ton of information in this, thinking about not only increasing, maximum decreasing, increasing, but the rate at which we increase, the steepness of those segments. Tons of information just from that picture. You can say much more in that picture than you can in all these words. Okay, so I think this is our last picture interpretation. So let's take a look at this picture down here at the bottom, and then they flip it to the other side. So we'll have to try to interpret this and then write down our thoughts on the next page. So here, our independent variable is time, and our dependent variable is that annual income. And so this is the annual gross income in relation to the number of years. Okay, so we got our person here, and their income is increasing fairly steadily. And it increases a little bit more slowly. Okay, so maybe, I don't know, inflation or something slow. They got a raise, but it wasn't quite as much as it had been the previous years. So they had been getting a steady raise. They got a smaller raise right here. So instead of maybe 50 cents per hour, it's only 30 cents per hour. I don't know, making up numbers here. There's no scale, so I get to estimate what's going on here. Then they got a pretty good raise, right? Their income increased pretty good. But uh-oh, this is a really dramatic decrease. So they maybe got laid off or lost their job. They had to pick up a new job, and that new job's starting salary was really low. But it allowed for some significant advancement. They're able to increase their wage pretty rapidly, but by the time they ended, they were back to where they started. Way back here before any of their raises. So they're not doing too good overall income wise. But at least they got their job again, some kind of job again. They lost a lot, and they lost a lot of their base wage. Okay, so that's the situation we're going to try to write about. Okay, so for several years, income rises steadily. Oops, I'm sorry, I have my book adjusted so you can see the bottom of the pages. I have to move it down further for the top. Okay. For several years, income rises steadily. Then they got that raise, and then there was a significant wage increase. So followed by a large wage increase. Okay. Then the person lost their job, and income dropped rather quickly. So we're making assumptions here about their losing their job. We're trying to get an interpretation for what this situation could mean. So they lost their job and income dropped rapidly. They were able to find a new job, but it didn't pay very much. Doesn't pay much, but it provides opportunity for raises, but provides good opportunity for income to increase. Doesn't pay much, but provides good opportunity for future income or for advancement. How will say that? Just trying to get the right words here. So they took a low paying job. So they had low income at first, but they were able to get high raises in that new position. And if we had more space to write, you could also add into this that they, at the end of the time, they still were just barely making up to where their initial income had been before all these changes. Okay, so these were all situations where we're able to read a story from a graph. Now we're going to do the reverse, try and create a picture from a story. So the first one's actually done for us right here. So let's read number 5. We leave home from Friday afternoon for a weekend getaway. Heavy traffic slows us down for the first half of the trip, but we make good time by the end. Express your distance from home as a function of time. So this is the heavy traffic segment where we're heading away from home, but kind of slowly. And then we make good time. So our speed increased, our line got steeper by the end of our trip. So this is just one example of trying to create a picture from a story. So let's look at the next couple of stories. So we just started a new job that pays $16 an hour with a raise of $2 per hour every 6 months. All right. So after 1.5 years, we're going to get a promotion that gives you a wage increase of of $5 per hour. My next raise won't come for another year. Sketch a graph over the first 2.5 years. Okay. So because it's every 6 months, I'm going to start my scale by halves. For 0.66 months is half a year. Then I'll have 1 year, 1.5 years, 2 years, and 2.5 years. They wanted to graph it for 2.5 years, so I wanted to get up to at least 2.5 right here. But I didn't have to go every single tick. It would have just crammed me down in there. So I did every other tick by 6 months or by half a year. Okay. Now, I don't need the beginning, so I'm going to zero out to the beginning with like a squiggle here. And then, because I don't need to do 0, 2, 4, 6, 8, instead I want to be able to see these a little better. So we'll start with, say, let's make this 14 and then 16 and then 18. Am I going to have enough scale? I'm going to need to start this one at 16. Let me start that one at 16. 18, 20, 22. Let's see if that will be enough. And if I need to go up to 24, I can. All right, so we'll start at 16 up here. Okay, so started my new job. and it pays $16 an hour. So 16's right here. I'm making $16 an hour. And I'm going to continue to make $16 an hour for the entire first 6 months. So I'm going to draw my line over towards 0.5 right there. Okay, this function, I'm going to get a $2 increase. So at that 6 month mark, I'm going to make $18 now. Now, this function is going to be a piecewise function. Because it's going to have these jumps in it, where I'm not going to connect these because a vertical line would not be a function. Instead, I'm going to put an open circle at that point to say it was 16 up to, but not including that day, because the very first day of the 6th month, boom, my salary jumped by $2. It didn't slowly increase from $16 to $16.25 and $16.15. It boom, 16 to 18. So that makes this piecewise. Okay. We'll talk more about piecewise functions in section 15, but we're kind of previewing it right here as we make these little graphs. Kind of cute. Okay. So it's going to jump again 6 months later. So I'm going to stay at 18. 6 months later at 1 year, I'm going to get $2 more. I put a solid dot here because that's the dot that's included. The one that's open is not included. That's the point of transition or change. I no longer make $18. Now I make $20. All right. So every 6 months. All right. After 1.5 years, though, I don't get $2. I get $5 more. So that's I'm at 20. Oh man, I got to get to 25. I don't have room for scale. So 24 is here. 25 is here. I had not computed how many number of times I need to add 2 before I set my scale here, so I could have done a little better job with that, but that's okay. $25 right here. And then my next increase won't come for another year. Now, they said I only had to draw this for up through 2.5 years. So I'm not getting another raise between 1.5 and 2 years. So I don't know how much my next raise is. So I don't know after 2.5 if I jump up to $2 more or if I jump up $5 more. They didn't tell me. So I'm going to stop my graph at that point. Okay. So that's my pretty piecewise function picture. These little bars that don't connect. They should not connect because there's a jump in the wage. It's not a continuous, it's a discrete jump in the wage. So it's continuous in between the segments, but it does not connect. All right, so that's one example. Okay, so the next one, we have a business, started slowly, and it lost money in its first 2 years. Okay, so we're going to lose money in the first 2 years. So it's going to start at 0, and it's going to lose money in the first 2 years. All right. Then it's going to break even in year 3. So by year 3, I have to be back up here at 0. All right. Then by the 4th year, you made as much as you lost in the first year. So I have to estimate this. About how far down are we after 1 year? And I have to be at about that much on the 4th year. Okay? Again, just kind of measuring with my eye how far down I was and trying to be up the same amount. Okay? So I'm up that same in the 4th year. Right there. Okay. And then what's happening next? Then we doubled your profits each of the next 2 years. Okay. So I have to be twice this high. So if I double, I'll be twice that high. And then if I double again, oops, be twice this. I'll be up there. So that is our picture. And again, we're just eyeballing that. Whatever this height was here, we were 2 times that height for year 6. All right. Two more quick little situations to try to draw pictures for. Situation number 8 is talking about hair growing at a steady rate. You're going to get it cut every month. Measuring the longest hair in your head, graph your hair length over the course of 6 months. Okay, so right now my hair is medium length. Yours might be long or short. And I'm going to let it grow for, I get it cut every month. Okay, so I'm going to let it grow for a month. My hair grows pretty slow, so it's going to grow a little bit for a month. Um, then this is the day I get it cut. So I'm trying to make it larger. This is supposed to be open. I'm going to write the word open just because my pen was a little too thick to make it look open. It kind of looks like it's filled in. It's supposed to be an open circle, like my piecewise function earlier with the hourly wage. This is also going to be piecewise. Okay. When I get it cut, I get it cut back to that same length it was. That's where it's going to have the closed circle. You can't have two closed circles on top of each other or it would fail the vertical line test and it would not be a function. Okay, so my hair is going to grow at about the same length. It kind of grows about the same length every month. So it's going to grow about the same length. So I'm going to have another open circle at about the same height because in 1 month it should have grown about the same length. And I'm going to get it cut again back down to where I like it. And it's going to grow again. Now you can keep this pattern going if you'd like to have your hair the same length all the time. Sometimes I like to get my hair cut even shorter though. So maybe, like, you know what? I am sick of this same length. I am going to chop it. So I'm going to get it shorter. And it's going to grow though, about at the same rate because hair doesn't grow more or less. And then I'm like, yeah, it's fine. It's fine. I'm going to let it grow back. Maybe I'll chop it again. Now it's really short. I got it buzzed. And then I'll let it grow again. And I'm done. So if you wanted to do the same length each time, you would have this pattern going on and on and on. These, where I went down lower, just meant I got a haircut where my hair is now shorter to start from. And it ends shorter. So there you go. I ended up with some real short hair. Okay. So it definitely needs to be a piecewise function. It's piecewise. These should not be connected because your hair does not go from 6 inches to 6 point. I mean, technically, when they cut off like little bits at a time, but they're not gonna cut off like a tenth of an inch, then a 15th of an inch, and so on. They're gonna just chop off a couple inches at a time. If you have long hair, they're just gonna buzz it off. It's gone instantly. Not instantly, but in terms of days and months, it's gone. It's like it's been cut. And so it should disconnect, not connect, because the length changes. You go into your appointment, you come out of your appointment, and the length is different. On the same day, the length is different. So it is a piecewise function where the segments do not connect because it's not a fluid transition between those lengths. It is cut. It is taken off. So there we go. All right. The last one. The situation says the distance traveled is a function of speed on a fixed time interval. Okay. So if I am traveling at a certain speed, the larger the speed, the larger the distance. It's kind of steady, right? The larger the speed, the larger the distance. So if my speed increases, my distance increases. If my speed increases, my distance increases. So this one might look just like that. It's going to connect because you're not going to your car it would be really horrible to drive in a car that went from 20 miles per hour to 25 miles per hour but didn't go through all the digits in between. It would like be really jerky. So that's not possible. It has to connect through all the speeds in between and all the distances between. You don't warp from position 0 to position 5. You have to smoothly connect in between them. So this one is continuous. Okay. This is a function that is not continuous. It is it has continuous segments followed by discrete breaks and more continuous segments and then some breaks in the piecewise functions. Again, talk about piecewise some more in section 115.